So in this video, I'm going to discuss authentication methods. There's specifically 4 methods I'm going to discuss in this video: basic authentication, session cookie authentication, JSON web tokens, and open authorization version 2. So to start with, basic authentication is something that really not recommended when you're dealing with the internet. It's often okay for testing or for working within a private domain, but it's really not used as much anymore and should be used with caution. So what happens is you've got a client and a server. So the client connected with TCP, and it has to do authentication. So what happens is it starts with a GET request for a web page. So it sends a GET for the index HTML file to the server. What will happen is the server is going to return a post response code 401. That means unauthorized. So the server is saying you're unauthorized until you provide the proper credentials. So that's all it is. It's a 401 response code, standard. So the server sends this security challenge for a username and password to the client. So the client returns an encoded user ID and password, and it uses base64 encoding. It doesn't use encryption, it's just encoding. And so it encodes the user ID and password credentials in an authorization header to the server. So you can see the authorization header's got basic there, and then the credentials are just sent, would be sent right after the keyword basic. So what happens is the server will check the user credentials, and if they're okay, it'll send post response code 200 to say it's okay. And then what would happen is each time the client sends any request to the server, it'll have to include that authorization header password with every request. So it's a little bit cumbersome. You consider that's got to keep sending the password with every request. That's how it's set up. As mentioned, this isn't encryption, it's just encoding. Then there's session cookie authentication. So in this case, session cookies are used, and they're quite common as well, particularly with e-commerce. So the client sends a GET request for the web page server, so it's at that point in the web browser process to load a web page. So it requests the index page. So the server gets that request, and it sends a login prompt for the username and password to the client. So the client returns the username and password for authentication. Server checks the client credentials, and if it's okay, it'll generate a cookie with a session ID. And that's then returned in the set cookie header as a response back to the client. The client sends a request with the cookie that has the session ID for authentication. So each time it's sending a request, it's having to send that with it for authentication. The server checks the session ID with local session database on the server for all requests. So it's having to verify it with a local database that it maintains on the server. So that'll take up some space as well, and it'll affect the server processing utilization as well. But it is stateful. Session cookies are stateful, so it can match the client with the server and follow that state right throughout the browser sessions. So it works well for things like e-commerce. Then this is JSON web tokens. And this really applies mostly to APIs. So if you're doing a lot of APIs, JSON web tokens are a really good choice. So what happens is you've got the client here, and now he's going to start communicating with a JSON web token authorization server. So the client sends a post request, this time with username and password. So it's not sending a GET, it's actually sending a post request, and this is quite common with APIs. It's sending data to the server initially with a username and password without being asked for it. So it sends that to the JSON web token authorization server. The JWT authentication server verifies the user credentials and issues an encrypted session token. The client sends all subsequent requests with the JSON web token in the authorization header. So you can see here it's actually called bearer now. It's not basic. It's the authorization uses bearer, and the JWT token is sent with it in the request. And the server authorizes the token from the client and sends the post response from the API if there's no issue with the token. And finally here I've got open authorization, or something called OAuth 2. And this is quite popular and used a lot. You can use it with APIs or really any sort of web-based transactions. So what happens is that you've got a client, you've got a what's called a resource server. That's webapp.com. You've got an authorization server at the back here, auth.server.com. So the browser will send an authorization request to the resource server, webapp.com. It's an authorization request. The web server will redirect that token request to the authorization server. The bearer token is generated from the authorization server and forwarded back to the client. So the client now has the bearer token it's looking for. So that client sends that bearer token in the authorization header to the web server with each request. So that's basically how that's set up. It's quite easy. The web server checks the token, sends the post response with 200 OK status to client, and if there's any problem with it, it'll send a 401 unauthorized to client if the token's invalid. And that's basically how open authorization works. None of these give you encryption, and encryption has to be provided by TLS. The other thing to keep in mind is that session cookies, this disadvantage is that you need to have to set up a database, session database for that. So that's just another consideration if you want to set that up on your web server or go with another kind of option.